Hello, everyone, and welcome. It is Wednesday and time for the Knowledge Bolide Hangout. You are looking at the beautiful sunset from our Knowledge Bolide member, Cameron Smith, out in Alabama.
Here we go. This is one that I've shown before, but I love looking at this one in the reflected cross-polarized light. This one's in line for the saw.
Boy, look at that big green chondrite on that.
Yeah.
Ooh. Whoa.
Yeah, and it's sticking out from the surface.
Oh, that's crazy.
And the subject of basalt was brought up, and more specifically, lunar basalt. So I unfortunately don't remember the YouTube commenter, but hopefully I told him to pay attention to this Wednesday because I'd have Mike Kelly answer that. So I'm going to turn the stage over to Mike Kelly, and kind of it's not really a question as much as please explain to us what a basalt is, how it differs from other rocks, how a lunar basalt is created, or basically any information on basalts and lunar basalts. We'd really appreciate it, Mike.
Yeah, certainly. So when you talk about rocks, you're talking, each rock has some certain characteristics. And when you get to basalts, what you're looking at is a characteristic where the rock itself has a fine-grained texture. So when you look at fine-grained minerals within a rock, that's usually caused by the rate at which they cooled when you're talking about igneous rocks. So basalt is a fine-grained igneous rock, which means that it's a rock that cooled quickly.
Right. So I've got a few different things to show. This one is an LL 3.15 NWA 13297.
Oh, that's beautiful.
And believe it or not, this is not cut. This is just a little fragment. That side shows some crust. But
Freezing and thawing with water inside those cracks. No, I just think it baked in the sun, and then at nighttime it froze. So,
yep.
But it's a nice end cut, and this is a special type of mesosiderite. It's classified as a 1A, and there are only 7 according to the Met Bowl.
Hey everyone. So I've actually been talking about this stone for a couple of weeks, but I can't get away from it, and I put my zoomer on today because I wanted to show some unique features.
Yes, sir.
So this one chondrite, or maybe clast, I don't know how you want to talk about it. I mean, you can, it almost like it has its own melt veins in it. And I'm not for sure if that's accurate, but I wanted to ask about it.
Yeah, that's a very interesting one. The lighter colored areas of it have little white flecks. So to back up a step, this is a type 3 ordinary chondrite, and quite possibly a primitive one of the lower 3.XX classifications.
I got together with John, and I was very happy to upgrade my Venalis.
Oh,
So
nice.
I had a slice that was 7 grams. So this is 3/4 of an individual with a nice shock on the one side where it's broken open, and nice crust on the other side. So that's
Beautiful.
a 22 gram upgrade from John. It's much appreciated. So this is NWA 12769. So this is an IVB. So there are 18 of those, I do believe. And along with that, I picked up a little bit of Hoba shale. So again, that's the world's largest single meteorite. I'm still on the search for a bit of pure iron of it. That piece, and this is the cool part, and putting it at the end over here.
There we go.
That is now a complete set of all of the main group irons.
That's crazy.
So there's a full slice of Taza. That is an iron ungrouped representative. Mount Dueling, a recrystallized 1C. A Goudal moving into the 2s, 2AB. This was the hardest one to get. Kumarina, I showed this about a month ago. That's a 2C. There's only, I think, 7 of those.
Yeah, I've never heard of it besides you.
One of Topher's favorites.
Yeah. Thanks for nothing.
Yeah, everybody loves nothing. 2D iron.
Then this is one from also unclassified from Stephen Amera that is a particularly beautiful little, probably primitive, but it's not been classified yet, but it's it'll be submitted soon.
Okay, so I have 3 specimens I wanted to show you today. Yes, here.
Yeah.
So yes, it's a nice example of oriented Gaogweni specimen.
Beautiful shape.
Yes. Wow.
So yes, very nice.
I like that.
And next, for the 2 others, those are meteorites from the Meteorite of the Month Club subscription. So this is the one from last month, from June. So this is Eucrite with a very nice dual lithology, as you can see. So I think it is not classified yet, but I think it is suspected to be a Eucrite melt breccia. So it will be classified very soon, but no number at the moment. So it is very nice.
Yeah, I was going to say, can we see? Well, that's a thick slice, buddy.
Absolutely.
Yes. Yes.
Wow.
Yes, I was surprised when I saw that in the package. Very thick and yes, beautiful.
Wow.
About 732 grams, and it looks okay from a ways away. But it looks pretty good close up too.
Wow.
Amazing.
That is a starry night of chondrules, man.
Oh,
Yeah, and it's pretty much nothing but chondrules.
yeah, way too many rocks.
They're in their cheek by jowl.
Talking about cheeks and jowl, Maxime, you're drooling.
Is the one this one I received it today. This is July Meteorite of the Month, and this is Martian Shergotite. So this is,
Yes.
no, it's reversed, but it is NWA 13187.
Yeah.
It's a nice size, I think, for a Martian. So I did not have any Martian of this size before. I'm really happy with that one.
If the magma gets into tiny little feeders that they call sills and dikes and gets close enough to the surface, it'll still cool really quickly, and you'll still get that same kind of fine grained texture to it.
Okay.
So that's a basalt as a whole, and I brought a couple of different things out to show, to give you examples.
Awesome.
So this is, again, they are mafic, so they're high in iron and high in and manganese, so they are going to be dark. So, just like when you look at the moon, you see the darker mares and you see the lighter highlands. Well, that's a function of the fact that, the basalts are typically blacks to dark grays. So this is a volcanic ashtray. So this
Okay.
this rock is about 10 years old now, and it was pulled out of a bit of flowing lava with a stick.
Whoa.
And it was basically formed right in front of where I was at.
Jeez.
Cool.
So yeah, that's a piece of lava from Hawaii
Very nice.
that was intentionally taken out and hardened, so I have a pristine specimen. And then things started to crystallize, and you start with certain minerals that crystallize at a higher temperature, and you slowly start to settle those out, and those are called cumulates, right? So they form first and settle out, and then the mix you have left doesn't have those same chemicals in it. So as the temperature starts to cool, the next mineral forms and comes out. So they look at it and looking at the different bits of basalt that we have, either as meteorites or as lunar return samples. They have about 24, 25 different kind of basalt chemistries that they've looked at, and they're not all the same. So they're saying that this lava that's forming these basalts, it's different in each area, and it's melting from different parts of the moon's mantle, and that's what's coming up. And the different parts that melt, since it's only regional and isolated, it has a different composition, and you'll get a different basalt out of it. Get the camera here. We got the Eucrites, off of Vesta, that are also considered basalts. Like I said, you got the Chondrites, which are Martian basalts, along with augite basalts. And again, all augite is it's a form of pyroxene. So it's one of the pure end members of pyroxene. So this just happened to be a basalt that only has augite, well, mostly only has augite in it as the pyroxene content. Black beauty pairings, again, those are the polymix. And there's something like, I think the new studies say there's something like 14 or more different lithologies of basalt in there.
Yeah.
And what's cool about those is they look at the different basalts in there, and they're not compositionally similar. So they're from different magmatic bodies.
Have our last show and tell of the night with Christian, who I think may be a first-time viewer. So thank you for joining us.
Well, thank you, Topher. Can I ask what is the correlation of the high metal with the small chondros?
We don't know exactly why, or at least I don't know exactly why. But the in the lower classes, the less metamorphosed classes of ordinary chondrites, the LLs tend to have much larger chondrules. The Ls are sort of in between, and the H's have small chondrules. Now,
we do take new viewers, new contributors, and also questions. So if you have a subject that you'd like us to discuss, please leave it in the comments, and don't forget to like this video. That was a wonderful hangout, and I really appreciate my Knowledge Bolide crew picking up the slack for me today. Really totally appreciate it, guys. Thank you, Mike Kelly, for the basalt presentation, and Maxime, stay sexy, buddy. I'll see you guys all next week. Thanks a lot. Bye-bye.
Bye, everybody.
All right. Have a good week, everybody.